we'll deal with shift registers. Now, what is a register? Register is a location where a data is stored. So normally a register stores 1 bit data. Okay, you can have registers with different sizes. So when we talk about registers in LCD, we are talking about flip-flops. Okay, so a flip-flop is a register which can store 1 bit data, which is stored in Qn. Okay, so Q is the whatever data you have in Q, that is the data that is stored inside the register, which you call the flip-flop. So a flip-flop is a 1 bit register. Now if you want n-bit register, so what do? You connect the registers in series. Okay, so or in cascade. So one of the output is connected with the input of the other. So shift register is normally constructed using D flip-flops. So shift register has different modes of operation. Basically it is, you can input data into a register and you can retrieve the data from the register. You can write and read from the register. Write into the register and read from the register. So how do you write into the register? You can do it serially or in parallel. Okay, so you can write serially or in parallel. You can also read serially or in parallel. So you can write, you can input data into the register in serial fashion and also in parallel fashion. You can read from the register in serial fashion and also in parallel fashion. So you have 4 modes of operation. One is serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. This is I. Okay. So SISO, SIPO, PISO, PO. These are the 4 modes of operations of a shift register. Okay, depending on how you are inputting the data and how you are outputting the data. So we'll discuss each of them in detail. So suppose we are considering 3-bit registers. Suppose, so I told that they are all D flip-flops. Shift registers are constructed using D flip-flops. So this is D2, this is Q2, this is D1, this is Q1, this is D0, and this is Q0. And this is how you get. So they are all synchronously connected. Suppose I'm giving them. Okay. So first we'll consider serial in, serial out. So in the case of serial in, serial out, I'm giving the input here. This is the serial input. And I'm taking the output from here. Serial input I'm giving here. What do you mean by serial in? I'm giving bit by bit. Only 1 bit at a time, that is serial input. Serial output means what? I'm taking the data 1 bit at a time. So Q2, Q1, Q0. So first of all, if any data is stored inside all these flip-flops, I'll remove it by making the clear equal to 0. I'm not showing that because the circuit will grow in size. So I don't want to make it complicated. So I'll just say that the initial condition is 0, 0, 0. Okay, by making all the clear tied to a switch, and that switch will be made equal to 0. So the initial condition will be 0, 0, 0 before I apply any clock. Okay, then only I will give the serial input. So as of now I have not given any serial input. Okay, so suppose my serial input I am going to give is 110. Okay, I am going to give 110. So how should I store this 110? 110, 1, this MSB1 should be stored in Q2, middle 1 should be stored in Q1, and the LSB0 should be stored in Q0. So I am pushing the data from here serially and taking the output from here. So ultimately I should have Q2 equal to 1, Q1 equal to 1 and Q0 equal to 0. That is my register content. Okay. So since I need Q0 equal to 0 and I am giving the data from this end, I will send the LSB first, not the MSB. Okay. So this data is sent first. So I'll give 0 here first. Then I'll give the clock. So initially everything is 0. So when I give a clock, what happens? Here it becomes 0. And whatever 0 was, so initially we had 0, 0, 0 here. So this 0 will come here, this 0 will come here. So again I am having these zeros only. This 0 will come here. This is my data. Okay. Next I'll give this middle one and I'll apply the clock. So what happens? That one will come here. This 0 will come here. This 0 will come here. So what happens? So this is my actual data. This is my actual data. Right? So 1 comes here, new 1. And this 0, which is my actual data, will come here. And this 0, which I had cleared and kept, that 0 comes here. Then I'll apply the next one, MSB, and apply the clock. So my 1 comes here, this red 1 comes here, this red 0 comes here. So I get my MSB. This 1 goes here, this 0 goes here. So now the data in each of my flip-flop is the actual data. So 1, 1, 0. So you can see that you have 3 flip-flops. At the end of 3 clock cycles, 1, 2, 3, I have my data stored. So in the case of serial input, I need n clock cycles to store the data just for serial input. I have not started taking it serially out because only now I have the whole data stored. Before, whatever was coming here was the cleared data, the initial data. Okay, so at the end of the third clock pulse, I have stored all the data, and also I have the first bit or the LSB bit at my serial out. Okay, so now I got the first data. Now I'm not going to serially input anything. I'm not going to serially input anything. I'm just going to give the clock. Okay, so what happens is this 0 goes. Okay, so I've already got this 0 at the third clock, at the end of the third clock pulse. Fourth clock pulse means Q0 gets what? This one. At the end of the fifth clock pulse, what happens? This one will come here. So I need 5 clock pulses to get or read or serially output all the data. So in short, this will be zeros because I am not inputting any data. And these two are my actual data. So serial input requires n clock pulses, where n is the number of flip-flops. Serial output requires, after serial input, at the end of that serial input, I get 1 bit. Then I require only n minus 1 clock pulses to get the rest of the bits. So for serial in, serial out, I require n plus n minus 1, that is 2n minus 1 clock pulses or 5 clock pulses. So that is serial in, serial out. Okay. So suppose I am considering serial in, parallel out. So at this particular point, after 3 clock pulses, I have serially input the data. Now suppose I am connecting Q2 to an LED, Q1 to an LED and Q0 to an LED. So at the end of the 3 clock pulses, I get the data in the 3 LEDs. That is parallel out. Parallel out means taking the output in parallel, simultaneously. So how many clock pulses do you need to parallelly output the data? None. You don't require any. Why? Because you are just using the clock pulses to serially input the data. To take the data out, you are just connecting it to an LED. You don't need any clock pulses because the data is already there in Q2, Q1 and Q0. Okay, so parallel out, you don't need any clock pulses. So serial in, parallel out requests, for serial in you require n, but for parallel out you don't require any clock pulses. So you require only n clock pulses. So that is serial in, serial out and serial in, parallel out. Okay. So serial in, parallel out you will show like this: Q2, Q1 and Q0. This is serial out, this is serial in, this is parallel out.